Let's look a little bit here now at simplifying radicals. This is like kind of freaky, actually. Oh, I don't know if it's going to work. But it's like, it's my screen inside my screen inside my screen. Okay. I don't know. Anyways. All right, simplifying radicals. Okay, so on the back of this worksheet, I've got 4 problems here just to start us off fresh. So, square root of 8. I can't take the square root of 8. If I try to take the square root of 8, I'm not going to get a nice number. So instead of rounding, sometimes we want the exact answer. So I simplify the radical. So I want to think about what's the biggest perfect square that goes into this number. So with 8, the biggest perfect square would be 4. Because to get 8, I can do 4 times 2. So basically, what I'm doing here is I'm thinking about 8, the square root of 8 as being the square root of 4 times the square root of 2. Well, the square root of 4 is just 2. So that comes out, the square root of 2, I can't simplify that. That stays under the radical. 90. So again, what's the biggest perfect square that's going to go into 90? Well, it's going to be 9. So 90 is 9 and 10. The square root of 9 is 3. The square root of 10, I can't simplify. 10 is 2 and 5. I can't take the square root of either of those. 216. All right, what's the biggest perfect square that goes into 216? Probably, I mean, 4 probably does, but there's probably something bigger. 9's not going to work, I don't think. I mean, 9 did go into it, but maybe there's something bigger. So after 9, I'd have 16, because that's 4 squared. After 16, 25 is probably not going to work. After 25, I'd have 36. So that looks like it's the best one. So 26, or 216, sorry, is 36 and 6. The square root of 36 is 6, so that comes out. And then I'd have the square root of 6. All right, 512. Same thing here with 512. I don't know, let's just start at 36. That didn't work. 49 would be 7 squared. 8 squared would be 64. Oh, but that 8 has, 8 is 4 and 2. So 64 times 4 is 256. That's 16 squared. So 512 is 256 times 2. So the square root of 256 is 16, so that comes out. The square root of 2 stays under. Okay? All right, now to the other side. All right, just a little review here. All right, mathematicians don't like having the radical in the denominator. So to get rid of it, we simplify the radical, and we multiply. So we just do square root of 3, whatever that number is there, you just do square root of 3 over square root of 3. Square root of 3 over square root of 3 is just 1, so you're multiplying the original one just by 1. So then up top, I'd have 3 square roots of 6. 2 times 3 is going to be 6. Square root of 3 times the square root of 3 gives me 3. These will cancel. So then I just have the square root of 6. Here, I'd multiply by the square root of 5 over the square root of 5. I'd have 4 times the square root of 10. 5 times 5 is 5. I can't reduce that any further. That would be the exact answer. All right, this one. But this is like doing a square root of 3 over 1. So if you have a fraction, like if I was dividing all this right here, I'd have a over b times, remember the bottom one, you have to flip the fraction. So I'd flip this. So I have 3 square roots of 2. Square root of 3 times the square root of 3 is 3. Those cancel. So this one I'd just be left with the square root of 2. All right, again over here. This flips. I multiply across 3. The square root of 2 times the square root of 2 is just 2. The square root of 3 times the square root of 3 is 3. So I end up with just 2. All All right, this one. All right, 3 square roots of 5 over the square root of 27 times the square root of 3 over the square root of 125. All right, if you, first of all, you don't have to do it this way, but I find it easier to reduce early on. I know that 27 is 9 times 3. The square root of 9 is 3, and then I still have another 3 under the square root. 125 is 5 times 25. The square root of 25 is 5, so I'd have 5 square roots of 5. So by doing that, these will cancel and these will cancel. This will cancel too. So I'm just left with that 5 there, so it's 1 over 5. Because I multiply across, it just have 1. Right there, it's just 5. Flip the bottom. All right, again, I could do the same thing I did before. If you don't want to do that, like the square root of, like you can kind of think about it. I mean, everything's under the square root here. So you just have 27 times 2, 8 times 3. Well, these right here, you'd only be left with 4. This right here, you'd be left with 9 up here. So then the square root of 9 is 3, the square root of 4 is 2. Down here, pretend this is just like x plus 3x. You'd get 4x. So here you have 4 square roots of 5. This can't combine with that one. This one we can simplify. This is like y, but this would be like 3x minus 5x. So that one has to stay by itself. But these would be minus 2 square roots of 5. The denominator is the same here. So I'd have 2 square roots of 3 over 2. Remember, you don't add the denominators. That would cancel. Denominators are different here, so I have to find a common denominator. But you know what's going to happen here when I switch this one? Since we don't like that square root sign, so I leave that one like that. This I'm going to change. Remember, I'm just multiplying it by 1. So I'm really not changing the number. I'm just changing how I write it. Now I have the same denominator. Well, there's no coefficient in here that I can put the 2 into, so don't worry about that 4 there. All right, this one has a multiplication, so you would FOIL. So the first square root of 2 times the square root of 2 is 2. The outer would be the square root of 6. The inner would be the square root of 6. And the last would be 3. So you'd have 2 plus 3, which is 5. And then this would give you 2 square roots of 6. Same thing here. The first, I'd have 2 square roots of 2. The outer, I'd have the square root of 6. The inner, I'd have 8. The last, I'd have square root of 6. So these I can combine. So 2 square roots of 2, 2 square roots of 6. Oh, sorry, did I do something wrong? Yeah, what did I do there? Here's the first. There's the outer. I think I did the outer again. There's the inner. The last is 4 square roots of 3. So there's actually nothing to combine there. There's nothing in common, so you just kind of would leave that answer like that. I'll write it better for you. Okay. All right, so again, when you're asked to simplify the radical, you want to make sure that you have all the perfect squares out, and you don't want a radical sign in the denominator. So you've got to do something to get rid of that radical sign in the denominator, and what we do is we multiply it, whatever that number is, over that self, and then that's considered simplifying the radical.